Hello class, so today we're going to look at production. And this is about, so now we're actually studying pure microeconomic stuff. So we're going to look at production and how do firms compute cost of production. So we're going to study what a production function is and what is a marginal product and how they are related. We're going to look at the various costs associated in running a firm and how are they related to each other and to output. And no matter how big or small the firm is, they all have very similar cost structure. So we're going to see how that cost affects output. We are going to assume that the firm's goal is to maximize profits. That is to maximize the total number of dollar value that enters the firm minus the total number of dollar value that leaves the firm. So profit is basically called total revenue. Revenue is what enters the firm when they make a sale, and cost is what leaves the firm, so what is needed to produce that product. So total revenue is the amount a firm receives from the sale of output, and cost is how much does it require to produce that output. So, and what we are assuming here is, and it's not something that is different, but actually all firms or most firms do operate this way. They want to make the profit number as large as possible. Now, there are two kinds of costs. Of course, explicit costs. Those are the ones that we actually make a payment from our pocket, from the firm's owner's pocket to someone else. So, for example, paying wages to workers, okay, paying rent on land. Those things requires an actual payment where we are actually making a dollar payment to a person or to machineries or to somebody. So those are called explicit costs. On the other hand, there is something called implicit costs, and they don't really require a cash outlay, but they are still costs, and these are the opportunity costs of the owner. So one of the principles that we learned is the cost of something is what you give up to get it. So in economics, we are interested in both implicit costs and explicit costs. So for us, total cost equals implicit plus explicit cost. So not only do we require or do we measure the cost of the payment of the inputs for production, but we also require the opportunity cost of the owner's time. So let's look at an example. Supposing that you need $100,000 to start your business and you go to the bank and the bank is charging 5% interest rate. So which means that if you borrow $100,000, you have to pay $100,000 back to the bank and 5% as interest payments. So 5% comes out to be $5,000. So let's say the first case is you borrow the $100,000 in full. The explicit cost is therefore $5,000 interest on loan because you have to pay that amount. Now, supposing instead you were using $40,000 from your savings and you borrow $60,000 from the bank. In this case, since you borrowed just $60,000, your interest rate is $3,000 on the loan. However, there is an implicit cost. The implicit cost is $2,000 because that's the amount you've given up. That's the interest rate that you have given up that you could have earned on your $40,000. You could have lent your $40,000 to someone else and earned that 5% interest or $2,000 extra dollars. So in both cases, the total cost, which is explicit cost plus implicit cost, are $5,000. So in accounting, they would just say, oh, case two is probably better because you're paying less interest rate. But in economics, we're saying like, no, they are basically the same thing because you're giving up earning of interest rate of about $2,000 so that you could basically start your business. So in both cases, we get $5,000. So this next comes accounting profit and economic profit. Accounting profit is total revenue minus total explicit cost. So when if you're an accounting student and you took accounting one, you will see that the way we measure profits in accounting is basically just total revenue minus Total explicit cost. What are the costs that are associated with producing the product? How much do we have to pay the inputs? Economic profit is basically total revenue minus total cost, which includes explicit and implicit cost. So the value, the opportunity cost, is also included in economic profit. So accounting profit ignores implicit cost, so it is higher than economic profit. Now next we come to the idea of production function. A production function is basically something that shows a relationship between how many inputs are used to produce a certain amount of output. So it can be shown in a tabular form or in a graphical form, but it basically tells us what inputs are required to produce what output. So it can be represented by table, equation, or graph. For example, let's say we have a farmer. His name is Farmer Jack, and he's growing wheat. Farmer Jack owns 5 acres of land. And so Farmer Jack can hire as many workers as he wants. So these are the things that we know about Farmer Jack. Now, if we want to know how many workers does he need to produce how many output, then we are using the production function. So let's say Farmer Jack hires no workers. Of course, if Farmer Jack hires no workers, no one is working in the farm, so there is no wheat being produced. So, of course, 0 workers means 0 bushels of wheat being produced. Now, if Farmer Jack hires 1 worker, output rises to 1,000. So, when he hires 1 worker, output goes up from 0 to 1,000 units. When he hires the second worker, total output rises to 1,800 units. When he hires 3 workers, it rises to 2,400. 4 workers, it's 28. 5, it's 3,000. So we can either look at it in a graphical form or in tabular form, but this is basically telling Farmer Jack that if he has 5 acres of land and if he increases the number of workers, his output, which is the number of bushels of wheat he can produce, goes up by that amount, or it becomes that amount. So from here, we want to know if and here's the thing that we talked about before, is like we always think at the margin. So if Farmer Jack hires 1 more worker, his output goes up by something, a unit we call is the marginal product of labor. The marginal product of any input is the increase in output when we increase the number of input by 1 extra unit, holding all the input constant. So what does that mean? If I'm increasing the number of workers that's working in the farm from 3 to 4 units, how much extra output is going to be produced? That is known as marginal product. So we use the notation delta to show change in. So the examples are, let's say, change in Q basically means change in output. Change in L means change in labor. So the marginal product of labor is change in quantity over change in the number of workers. So if I increase my worker from 3 to 4 units and my output goes up by 300 units, then the marginal product of labor is 300 units for that. So let's look at a little better example. Now, if you increase your worker from 0 to 1, your output goes up by 1,000. So your marginal product of labor is delta Q over delta L, which is 1,000. So when you hire 1 extra worker, your output goes up by 1,000 bushels. Now when you hire another worker, so your number of workers is going up from 1 to 2, your output is going up to 800. So that means that the first worker is contributing 1,000 units. The second worker is actually contributing just 800 units. Similarly, the third worker, if you hire another worker, the third worker will only contribute 600 units. The fourth worker will contribute 400, and the fifth worker will contribute just 200. So as we can see, the marginal product of labor is actually falling as we add more workers. Now, why is that? Well, one thing that we learned is rational people think at the margin. So if Farmer Jack hires an extra worker, his cost is basically rising by the wage he's paying to the worker because that's how much he has to pay to hire that worker. His output rises by the additional amount that the extra worker is producing in the firm. So comparing them makes Jack decide then whether he should hire the extra worker. So if the amount the worker produces is more than the wages that he's being paid, that's when Farmer Jack decides that yes, I should hire this worker. If the amount that the worker produces is less than the wages that is being paid to that worker, then Farmer Jack should not hire that worker. So why does MPO diminish? Because as Farmer Jack adds more workers, the average worker has less land to work. We said that the land is fixed at 5 acres. So they will, after a while, the two workers will just get into each other's way. They will not have enough land to work on. Some workers will be slacking off. In general, whenever we keep on adding more workers, as we hold other inputs constant, like land or capital or resources available to the workers, then your marginal product, that is the contribution of the additional worker to output, will keep on falling as the number of workers keep on increasing. And this is what we call diminishing marginal product. So the marginal product of an input falls as the quantity of the input increases. So as we keep on raising one level of input, holding all the other inputs constant, the marginal product of that input will keep on falling. Now let's look at the cost side. Supposing Farmer Jack must pay $1,000 per month for land, regardless of how much wheat Farmer Jack produces. So if Farmer Jack produces 0 bushels of wheat, he still has to pay $1,000 per month. If Farmer Jack produces 5,000 bushels of wheat, Farmer Jack still has to pay $1,000 per month. Let's say the market wage for workers is $2,000 per month. So Farmer Jack's costs are related to how much wheat he produces. The first part, the $1,000 per month, that cost is fixed. It's like rent. So no matter how much you produce, you still pay the same amount as rent. Okay? So cable bill can be fixed cost. So basically, no matter how little or how much TV you watch, you still pay a fixed amount as cable bill. So that's kind of like the cost that we're talking about, the $1,000 per month. Now, if we look at this, we have number of workers and bushels of wheat. No matter how much Farmer Jack produces, the cost of land is still the same, $1,000 per month. That's probably the amount of rent he has to pay. The cost of workers goes up as he hires more workers. If each worker costs $2,000, then when he hires one worker, total cost is $2,000. When he hires 3 workers, total cost of labor is $6,000. When he hires 5 workers, the cost of labor is $10,000. So total cost is therefore the sum of cost of land and cost of labor. So we just add those two and we say, all right, if he's producing nothing, if he hires no workers, then Farmer Jack still has a total cost of $1,000. If he hires 5 workers, then he still has to pay $1,000 to land, but his cost of labor is now $10,000, so his total cost is $11,000. Now, we talked about marginal revenue, or sorry, marginal product of labor. Now let's talk about marginal cost. Marginal cost is the increase in total cost when we produce one extra unit. So what is the cost of producing an additional bushel of wheat in this case? So if we go back to our example, we're looking at the total output that we have and the total cost that we have. And if we want to calculate marginal cost, if we increase our output by 1,000 units, so from 0 to 1,000, our total cost just changes by $2,000. Okay, because if we have 0 bushels of wheat being produced, the total cost is 1,000. If we are producing 1,000 bushel of wheat, our cost is 3,000. So total cost goes up by $2,000 when we're producing 1,000 extra units. So the marginal cost is change in total cost divided by change in quantity, which comes out to be $2. For the second one, as we can see, change in total cost is $2,000, but change in quantity is 800. So our marginal cost, that is, if we wanted to produce, let's say, the 1,801 unit, our cost would be, extra cost would be $2.50. And so on. So in this case, if we want to produce the 2,401 units, that extra 1 unit is going to cost $3.33. And so on. So as you can see, as we produce more, our marginal cost keeps on going up. Why is marginal cost important? Well, Farmer Jack is rational and wants to maximize his profit, and that's what we assumed initially. That all firms, in this case at least, we assume that firms want to maximize their profit. So we want to know, okay, if he is producing a certain amount and if he wants to increase his profit, should he produce more or less wheat? To find that answer, he has to think of the margin. So if the cost of additional unit of wheat is less than the revenue that he is generating from that selling that extra amount of wheat, then his profits will rise if he produces more. Because if we think about it, the extra unit of wheat is going to, let's say it brings him $5. And to produce that extra unit of bushel of wheat, it just costs him $3. Then, if he sells that extra unit, if he produces and sells that extra unit is going to bring a profit of $2. 5 minus 3 is 2. So he should increase his production. If on the other hand, the marginal cost of producing that extra unit of or bushel of wheat is $7, and the revenue that the extra unit of wheat is going to bring in is $5, then it costs him more to produce it, but he gets less amount. So he's losing $2 when he produces that, so he should not produce the extra unit of wheat. So now we come to a few ideas. We already looked at the cost structure. These are just naming them differently. Fixed costs are costs that do not vary with the quantity of output produced. So in Farmer's Jack case, fixed cost is $1,000 that he pays for his land. So some of the example of fixed cost is rent that we pay. No matter how much we stay in our apartment, we still pay the same amount as rent. Cable bill is fixed cost because we pay the same amount no matter how little or how much we use cable. Internet bill is also fixed cost, so those things don't change as we consume more output. Other examples are cost of equipment. If we purchase an equipment, the cost that it is that we have to pay for renting that equipment, or loan payments, rents, all these are fixed costs. Variable costs, on the other hand, are the ones that vary with the amount that we produce. So, for Farmer Jack, variable cost is the wage. Other examples are, let's say, cost of materials, cost of utilities, so electricity bill, water bill, all those things are variable costs. So if we produce more, we will probably use more electricity or more water, and so those costs will go up. So total cost that we have is fixed cost plus variable cost. So in this case, let's look at an example. If the quantity I'm producing are those quantities and my total cost is 0, 170, 220, or when I'm producing 5 units, it's 380. Average total cost is basically cost per unit, total cost per unit. So average total cost is total cost divided by quantity. So for the first one, we have 0 because, total cost divided by 0 is an undefined number. But let's say for the second unit, so our total cost is 220. If I'm producing 2 units, then my average total cost is 220 divided by 2, which is 110. We also have two different kind of measure. AFC is average fixed cost, and AVC is average variable cost. So in the first case, of course, our average fixed cost is, or our average total cost was not available. Average fixed cost is basically fixed cost over quantity. So let's write this. 10 average fixed cost. This is fixed cost divided by quantity. And average variable cost is variable cost, total variable cost divided by quantity. So in this case, even if we're producing 0 units, we still have a total cost of 100. So that means that our fixed cost is, let's write it here, fixed cost is 100. Because even without production, we still have to pay that amount to, let's say, as rent. So if this is our fixed cost, then for this amount, if we're producing 1 unit and our fixed cost is 100, then our average fixed cost is 100 over 1, which is 100. For this amount, our fixed cost is 100, so 100 over 2 is 50. 100 over 3 is 33.3, 100 over 4 is 25, so this is basically 100 divided by 4 equals 25, and so on. Now, what about average variable cost? Okay, so if my total cost is 170, fixed cost is 100, then my variable cost is 70. So 70 divided by 1 is 70. Now let's look at this one. If my total cost is 220, and I say that my fixed cost is 100, that doesn't change as we produce more. So for when quantity is 2, let's write it here, when quantity is 2, then my variable cost is total cost minus, which is total cost is 220. So 220 minus total fixed cost, which is 100. Okay, which comes out to 120. So this is my variable cost. Now, if I want to find average variable cost or variable cost per unit, then it will be total variable cost, which is 120, divided by 2, which is 60. So it is 120 divided by 2, and you get 60. So we do the same thing for each of them. So let's say, let's use this example. Total cost is 480. So my fixed cost is 100. Therefore, variable cost is, for this example, must be 380. Okay. So if it's 380, then the average variable cost is, AVC is 380 divided by 6, because we're producing 6 units, which comes out to be 63.3. So you should try practicing them, do all of them, and then see if you get similar answers. If you do that, then you will have a good grasp on average total cost, average fixed cost, average variable cost. Now, costs in the short and long run. In the short run, some inputs are fixed. So for example, you need to have a contract to rent a place. And so normally the contracts are about a year long or 2 years long. So you can't, if you break a contract, it creates a lot of issues. So technically, you have to pay rent for, let's say, the next year or 2 years. So these costs are fixed. However, in the long run, all inputs are variable. Because at the end of your contract, you can decide whether you want to renew the contract or not. If you don't want to renew it, you can just let it go. And so in the long run, all inputs become variable. So in the long run, the average total cost, you want to basically in the long run, because of trial and error, you learn about your business and everything. Your average total cost, that is how much the cost per unit, the total cost per unit, is basically because you learned your trade and everything, you're using the most efficient mix of inputs to produce that output. So you finally figured out what factory size or what farm size or what kind of resources do you need to produce the output at the lowest cost per unit. And so that's what we want to do, because once we produce it at the lowest cost per unit, then that means we can actually help to raise our revenue or raise our profits. And so next we are going to use this cost structure to understand how it applies to different kinds of firms. Okay, well, have a good rest of the day, and we're going to talk about chapter 14 next time.